Everybody, welcome back. We're on page 10 of 6.3. We're going to learn how to add and subtract rational expressions. So there's going to be two cases. The first case is when denominators are the same. If two rational expressions have the same denominator, you just either add or subtract the numerators and rewrite the answer as a rational expression with the new numerator over the denominator. Very straightforward. So I don't even have an example of that. Let's do case 2 where denominators are different. So to add or subtract fractions when denominators are different, you must write equivalent fractions with the same denominator. So in the first example, I have highlighted right here, we have 10 over 3x minus 12, subtract 3 over x minus 4. So sometimes it's easier to factor them to get the common denominator, so that's one of the steps I really recommend you do right away. So what I did was in the first one I factored out a 3 out of the 3x minus 12, and I got 3 bracket x minus 4. So you'll notice very similar now. The only thing I have to do is I have to multiply the denominator by 3, which you can see here that I've done right here. And whatever you do with the denominator, you do the numerator. Okay? So then I get a common denominator. So maybe I should put that at the beginning just so you can see it there, right? So 3 is now multiplied by the numerator and denominator. And once we do that, then we just put them all over the same numerator, 3 bracket x minus 4, and we have 10 subtract, well, 3 times 3 is 9. So that's the next step. You can probably do that as one step. And then 10 minus 9 is 1, so our final answer is 1 over 3 bracket x minus 4, and x cannot equal 4. And you get that from both of the denominators. Your non-permissible values. Thank you. Okay. So when adding or subtracting rational expressions, you use any equivalent common denominator. However, you usually lose the lowest, right? So I usually do the lowest. Again, that's completely up to yourself. So let's take a look at the first example. I'm going to steal this one just to get our self ready here. Okay. So hold. There we go. So the first one is 2x plus 4. Again, we don't really have to do anything with the numerator. I recommend just leaving it. The denominator needs to be factored here, obviously. It's a difference of squares. Right? So it's x minus 3x plus 3. Okay? And the next one, so now we have the plus. I fixed this. It's going to be plus 7x minus 10. Alright. So we add 7x plus 10. Alright. And doing so, we get 9x. That's minus 10. That's a 9x minus 6. Okay. And then we can factor out a 3, and that leaves you with 3x minus 2, and finish there. There's nothing we can do with that. That's it. Pretty easy one that we don't have to find a common denominator. And remember, don't forget about your non-permissible values. So x can't be plus or minus 3. Right? So x cannot be plus or minus 3 or x minus 3. Whatever works for you. Okay, I'll make that red. Alright, and that's it. Let's look at the next example. They use AB, it doesn't make a difference, it's fine. Okay. Again, this is just subtracting, pretty straightforward. Equals, for a fraction here, remember we get 10, A plus 5. Remember AB, it's a common denominator, you can't factor anything there. I don't factor the numerator because we're going to have to calculate terms anyway. Remember, it's subtract. We're going to put a bracket here, 3a minus 2, because if you're subtracting, everything has to be subtracted, so the terms will change. So it's going to be subtract 3a, and remember, it's minus negative 2, so that's actually plus 2. Okay. going to we're going to add like terms. We're going to get 7a, and it's going to be 7, right? And I always factor just to make sure. Probably seeing them, you're not going to get anything here. That's fine. There's your final answer, simplified. Nothing else we can do. You could take an a out, then an a could have been divided, but that wasn't the case here. And a lot of you are looking at your non-permissible values. You're probably saying a and b, so we just put a comma b, and that can't be equal to 0, right? It can't be equal to 0 because if they're multiplying here, right? So either value would give you a value of 0. Alright, so that's it for page 10. Let's go to some of the cases where we don't have a common denominator. So the first thing, let's do a little practice on finding a common denominator. So the common denominator here, you just multiply this, right? So this has a 2, 3, and a 1, so it's going to be 6, right? And sorry about that. So it's going to be 6. They both have an x, so we can just have an x, and this one has a y. So the common denominator would be 6xy. Simple as that. Okay? So the next one we have, and these are 3 different rational expressions. So this is an x plus 5, this has an x plus 5, this has an x minus 4, this has an x minus 4, this has an x plus 7. So we have to have all the same ones, right? So all we need to do here is write in the common denominator. So I'm going to steal x plus 5. We don't need to write it again because the second one already has it. That's x minus 4, and then we don't have to write the x minus 4 again, and we're done. That's it. So that every denominator here is going to need to have these 3 factors: x plus 5, x minus 4, and x minus 7. You don't have to double them up if they're already there. Okay? Let's take a look at the next one here. We have 1 over x squared plus 6x plus 9 and 1 over x squared plus 8x plus 5. So what you want to do is you want to factor these first before you're trying to find a common denominator. See if there's any common factors in the denominators. So the first one, as you can see, we'll factor 2x plus 3x plus 3 in the denominator. The numerator doesn't change. And then the second one is x plus 3x plus 5. Okay, so I just factored them. So you notice both have a common x plus 3, x plus 3. So in this case, you will need both x plus 3's because it's in the same one, right? Before, we only needed x plus 5 because it was in 2 separate terms. But in this one, you'll need both because there's 2. So the common denominator will look like x plus 3, x plus 3, x plus 5. Okay? So these are just a couple different ways I wanted to show you before we move forward. Okay? So let's look at page 12. The first one here, we have 3 terms being added, subtracted. We have 2x over xy. We have 4 over x squared, and we have 3 over x. So the common denominator is going to be, I'll write the common denominator right here. It's going to be, you probably guessed it, x squared y. Okay? So we have to make each of them x squared y. So what I'll do is I'll insert an equation. There we go. There. Apologies. Okay. So we have x, xy, which would be x squared y. Okay. So that's the common denominator. So the first one, what I like to do is rewrite it. We'll show you what we're changing from the original. So I'm going to rewrite the original here first for you. So what you do is I'm going to leave this one black this time. We're going to leave that here, and what we're going to do is we're going to multiply by, and I'll make that the red color. We're going to multiply that by what we need. So remember, our common denominator is going to be x squared y. So to do that, we're going to need to multiply by x. Whatever you do to the denominator, you have to do to the numerator. Remember that? Okay. Same thing here. And same thing here, right? Because we have three different terms we're dealing with, right? So this here needs to be a y and a y. Alright, so now what we're going to do is we'll multiply these terms. Alright, so I'm going to insert, wait, we're getting an equation here. Sometimes this is tricky here. Alright, so when we multiply that, we'll get 2, and the x is going to be squared. We have 2x squared over x squared y, right? Because we multiply the x by the numerator and the denominator. Alright, then it's going to be plus, and we're going to have 4y, and the denominator is going to be the same as our previous, right? Because that's why we did multiply by the y, x squared y. And then we have minus, and then it's going to be 3xy in the numerator, 3 times x times y, 3xy, and the denominator again, like I said, will be the same. That's why we did. Okay, so now I will copy I'm only going to copy the denominator, or the first term, sorry, because the rest will all be added, right? We're going to have that common denominator is all the same, so it's going to be 4y minus 3xy. All right? And we combine any like terms if we can. There's no like terms. There's no coefficient we can take out, so that's it. It's finished, actually. And remember, there's our common denominator. I'll get rid of that. That was just to show you what it was. Okay? Or you can leave it. It's up to yourself. And remember, x can't be 0 and y can't be 0 here for your non-permissible values. Okay? So x can't be equal to 0, and then I can just put, instead of doing both, I can just put them x, y, right? And there's your non-permissible values. I state them anyway, even if it doesn't say to it. It does in this case, but just get used to that. There's your common denominator. It's all over one, and you're finished. Okay. What we'll do is we'll stop there, and then we'll finish off B, C, and D in the next video. Okay. So hope that worked out well for you there. There's your final, and we'll go from there in the next video. Thank you.